Chapter 1, How Seasons Occur Part 1, Summary 1000 words, Introduction. This chapter introduces one of the most fascinating natural phenomena on Earth, the occurrence of seasons. Every year, we experience changing weather patterns such as summer, winter, monsoon, and spring. The chapter explains why the duration of day and night changes, how the Earth's rotation and revolution affect sunlight, and how these lead to seasonal changes in different parts of the world. The chapter connects basic astronomical concepts, the Earth's rotation, revolution, and the tilt of its axis, to everyday experiences, such as longer days in summer and shorter days in winter. 1. Rotation of the Earth. The Earth rotates around its own axis once in 24 hours, from west to east. This rotation causes the alternation of day and night. The side of the Earth facing the Sun experiences daytime, while the opposite side, away from the Sun, experiences night. Due to this rotation, we experience sunrise, noon, and sunset daily. The Sun seems to move across the sky from east to west, though it is actually the Earth rotating from west to east. The rotation is also responsible for the measurement of time in days. This daily motion is the foundation for understanding larger patterns such as seasonal changes. 2. Revolution of the Earth. Apart from rotating on its axis, the Earth also revolves around the Sun in a slightly elliptical, oval-shaped, orbit. It takes 365 days and 6 hours, 1 year, to complete one revolution. This revolution, combined with the tilt of the Earth's axis, is the main reason behind the formation of seasons. When the Earth revolves, the position of the Earth relative to the Sun keeps changing. Consequently, different parts of the Earth receive varying amounts of sunlight during the year, causing temperature variations that define different seasons. 3. Tilt of the Earth's axis. One of the most important facts to understand is that the Earth's axis is tilted at an angle of about 66½ degree to its orbital plane, or 23½ degree to the perpendicular. This tilt means that the northern and southern hemispheres are not equally facing the Sun throughout the year. When the northern hemisphere is tilted toward the Sun, it experiences summer, while the southern hemisphere experiences winter, and vice versa. Thus, the tilt of the Earth's axis causes unequal heating of the Earth's surface and leads to seasonal variation. 4. Change in the Sun's apparent position. If we observe sunrise and sunset throughout the year, we notice that the position of the Sun on the horizon changes. Around June 21st, summer solstice, the Sun rises and sets farthest north of the east-west line. Around December 22nd, winter solstice, the Sun rises and sets farthest south of the east-west line. On March 21st and September 23rd, equinoxes, the Sun rises exactly in the east and sets exactly in the west. These are the days when day and night are equal everywhere on Earth. This shifting of the Sun's apparent path in the sky throughout the year explains why shadows change in length and why day lengths vary in different months. 5. Duration of day and night. The duration of daytime and nighttime depends on the tilt of the Earth's axis and its revolution around the Sunday. During summer, when a hemisphere is tilted toward the Sun, days are longer and nights are shorter. During winter, when the hemisphere tilts away from the Sun, nights are longer and days are shorter. During equinoxes, both hemispheres receive equal sunlight, resulting in equal day and night. For example, in India, northern hemisphere, June 21st has the longest day and shortest night. Around December 22nd, India experiences the shortest day and longest night. Around March 21st and September 23rd, the duration of day and night is almost equal. This pattern repeats annually, forming the cycle of seasons. 6. Observation and experiment. The textbook encourages students to carry out practical observations. Recording sunrise and sunset timings every few days over several months helps understand how the duration of daylight changes. Using a stick or rod fixed in the ground, one can observe the direction and length of shadows at sunrise and sunset to see how the Sun's position shifts across the horizon during the year. These simple activities reveal that the sun's apparent path changes gradually, a key indicator of seasonal change. 7. Relation between rotation, revolution, and seasons. The rotation of the Earth causes day and night, but seasons occur due to its revolution around the sun and the tilt of the axis. Without the tilt, every place on Earth would receive the same amount of sunlight throughout the year. There would be no distinct summer, winter, spring, or autumn, only similar weather all year round. Thus, the combination of the Earth's tilt and orbit around the sun makes our planet's climate dynamic and life-supporting. 8. Understanding solstices and equinoxes. There are 4 important positions of the Earth in its orbit around the sun. 1. Summer solstice, around June 21st, the northern hemisphere tilts toward the Sunday. The sun's rays fall vertically on the Tropic of Cancer, 23½ degree N. Longest day and shortest night occur in the northern hemisphere. It marks the beginning of summer in India. 2. Winter solstice, around December 22nd, the southern hemisphere tilts toward the Sunday. The sun's rays fall vertically on the Tropic of Capricorn, 23½ degree S. Longest day in the southern hemisphere and shortest day in the northern hemisphere. Marks the beginning of winter in India. 3. Vernal equinox, around March 21st, the sun's rays fall directly on the equator. Day and night are equal everywhere. Marks the start of spring in the northern hemisphere. 4. Autumnal equinox, around September 23rd, again, the sun's rays fall directly on the equator. Day and night are equal everywhere. Marks the beginning of autumn in the northern hemisphere. 9. Effects of the seasons on life and environment. The change in seasons affects all living beings and natural processes. Human life, agricultural activities, festivals, and clothing depend on the season. Plants, certain crops grow only in particular seasons, e.g., wheat in winter, rice in summer. Animals, many animals migrate or hibernate according to seasonal changes. Climate, temperature, rainfall, and wind patterns are influenced by seasonal shifts. This cyclic change ensures ecological balance and diversity on Earth. 10. Key takeaways. The Earth rotates on its axis and revolves around the Sunday. The Earth's axis is tilted at 23½ degree to the perpendicular. Seasons occur due to the tilt of the axis and revolution around the Sunday. Solstices and equinoxes mark major seasonal points. The length of day and night changes throughout the year. Both hemispheres experience opposite seasons at any given time. Conclusion. The occurrence of seasons is one of the most beautiful examples of how astronomy shapes our environment. The tilt of the Earth's axis and its yearly journey around the sun make our planet dynamic, creating variations in temperature, light, and life. Without these changes, life would lack diversity. Understanding the mechanisms behind seasons not only connects us to geography but also helps us appreciate the balance and rhythm of nature. Full moon symbol. Chapter 2, The Sun, the Moon, and the Earth. Summary. 1000 words. Introduction. The Earth, Moon, and Sun are 3 closely related celestial bodies whose interactions govern the cycles of day and night, months, tides, and eclipses. This chapter explains the movements of the Moon, its phases, and the phenomena of solar and lunar eclipses. It also highlights the scientific understanding of these events, dispelling myths and superstitions surrounding them. 1. The Sun, our source of energy. The Sun is a medium-sized star located at the center of the solar system. It provides light and heat energy essential for all life on Earth. Without the Sun, there would be no photosynthesis, no weather, and no life. The Sun's energy regulates the climate and seasons, causes winds, rainfall, and the water cycle, enables the growth of plants and supports the food chain. Because of the Earth's rotation and revolution, the amount of sunlight falling on each region varies daily and annually. 2. The Moon, Earth's natural satellite. The Moon is the Earth's only natural satellite. It is the 5th largest moon in the solar system and is about 384,000 kilometers away from the Earth. It does not have its own light. It reflects the sunlight that falls on it. The moon's surface is barren, rocky, and full of craters, with no water or atmosphere. Hence, there is no life on the moon. However, because of its closeness to the Earth, it influences several natural processes, such as tides. 3. The motions of the moon. Like the Earth, the moon performs two important motions: rotation and revolution. 1. Rotation. The moon rotates on its own axis once in about 27 days 8 hours. 2. Revolution. It revolves around the Earth in the same time 27 days 8 hours. Because both take almost the same time, the same side of the moon always faces the Earth. This is why we never see its far side from Earth. This synchronous rotation is an important characteristic of the moon's motion. Additionally, as the moon revolves around the Earth and the Earth revolves around the sun, the moon indirectly revolves around the sun too. 4. Perigee and apogee. The moon's orbit around the Earth is elliptical, oval-shaped. Therefore, its distance from the Earth changes slightly during its revolution. Perigee, the position when the moon is closest to the Earth, about 356,000 kilometers away. Apogee, the position when the moon is farthest from the Earth, about 407,000 kilometers away. This difference in distance slightly affects the size and brightness of the moon as seen from Earth. 5. Phases of the moon. The moon does not shine by its own light. The portion of the moon that we see shining is the part that reflects sunlight. As the moon revolves around the Earth, the visible portion of its illuminated side changes, creating the phases of the moon. There are 8 main phases in one lunar cycle, about 29 1/2 days. 1. New moon, Amavasya. The moon is between the Earth and the sun, and the side facing the Earth receives no sunlight. It appears invisible. 2. Waxing crescent, a small curved portion becomes visible. 3. First quarter, half of the moon is visible. 4. Waxing gibbous, more than half of the moon is visible. 5. Full moon, Purnima. The entire face of the moon is visible as it is opposite the sun. Day 6. Waning gibbous, the visible portion starts decreasing. 7. Last quarter, half of the moon is again visible but opposite side. 8. Waning crescent, only a thin slice remains before it becomes new moon again. This waxing, increasing, and waning, decreasing, of the moon occurs regularly each month. 6. The angle between the orbits of the Earth and the moon. The Earth's orbit around the sun and the moon's orbit around the Earth are not in the same plane. The moon's orbit is inclined by about 5 degrees to the Earth's orbital plane, the ecliptic. Because of this inclination, the sun, Earth, and moon do not always fall in a straight line during a full moon or new moon. Therefore, eclipses do not occur every month. Eclipses happen only when all three are aligned in the same plane. 7. Eclipses. Astronomical events. When the sun, Earth, and moon align in specific positions, the light from one body is blocked by another, creating an eclipse. There are 2 main types: 1. Solar eclipse, Surya Grahan. 2. Lunar eclipse, Chandra Grahan. Let's understand both. 8. Solar eclipse, Surya Grahan. A solar eclipse occurs when the moon comes between the Earth and the sun and casts its shadow on the Earth. This happens only on a new moon day when all 3 bodies are in one line. The shadow has 2 parts: umbra, dark shadow, the region where the sun is completely blocked. People here see a total solar eclipse. Penumbra, light shadow, the region where the sun is only partially covered. People here see a partial solar eclipse. Types of solar eclipses: 1. Total solar eclipse, the moon completely covers the sun, the sky becomes dark for a few minutes. 2. Partial solar eclipse, only part of the sun's disk is covered. 3. Annular solar eclipse, when the moon is at apogee, farthest, its shadow does not fully reach the Earth. The sun appears as a bright ring or ring of fire. The duration of a total solar eclipse is maximum 7 minutes and 20 seconds. It is visible only from a narrow region on Earth. Important note: never observe a solar eclipse directly with the naked eye, it can damage the eyes. Use dark glasses or special solar filters. 9. Lunar eclipse, Chandra Grahan. A lunar eclipse occurs when the Earth comes between the Sun and the Moon. The Earth's shadow falls on the Moon, making it appear darkened or reddish. This happens only on a full moon day when all three bodies are in the same plane. Types of lunar eclipses: 1 total lunar eclipse, the Moon is completely covered by the Earth's shadow. 2 partial lunar eclipse, only a part of the Moon enters the Earth's shadow. The maximum duration of a total lunar eclipse is about 107 minutes, much longer than a solar eclipse because the Earth's shadow is larger. Lunar eclipses can be observed safely with the naked eye, unlike solar eclipses. 10. Why don't eclipses happen every month? Even though the Moon is between the Earth and the Sun once every new moon, and opposite the Sun during a full moon, eclipses do not occur every month because the Moon's orbit is tilted by 5 degrees. Only when the three bodies fall in one line, in the same plane, during a new or full moon does an eclipse occur. 11. Occultation and transit. Apart from eclipses, there are other interesting astronomical events. Occultation, when the Moon passes in front of a star or a planet and temporarily hides it from view. The total solar eclipse itself is a form of occultation where the Moon hides the Sun's disk completely. Transit, when an inner planet, like Mercury or Venus, passes between the Earth and the Sun, it appears as a small dark dot moving across the Sun's surface. A transit is like a mini eclipse. These events help scientists study celestial motions and the nature of the Sun's light. 12. Scientific understanding and myths. Eclipses are purely astronomical phenomena caused by the alignment of celestial bodies. There is nothing auspicious or inauspicious about them. Unfortunately, superstitions about not eating or going out during eclipses have been widespread in many cultures. The textbook encourages students to understand that science, not belief, explains these events. Scientists and astronomers often travel to places where eclipses are visible to study the Sun's corona, outer atmosphere, the Moon's surface brightness, the Earth's atmospheric effects on sunlight. Such research improves our understanding of the solar system. 13. Effects of eclipses on nature. During a solar eclipse, the sudden darkness confuses many animals and birds, causing them to behave as if it were night. They stop chirping or return to nests. These temporary changes show how strongly life depends on sunlight. 14. Key facts and figures. Solar eclipses occur only on new moon days. Lunar eclipses occur only on full moon days. The Moon's orbit is inclined at 5 degrees to the Earth's orbit. Maximum duration, solar eclipse, 7 minutes 20 seconds. Lunar eclipse, 107 minutes. The Moon's perigee equals closest point, apogee equals farthest point. Always use protective eyewear for solar observations. 15. Conclusion. The chapter beautifully links astronomy with everyday observation. The Sun, Moon, and Earth are engaged in a delicate cosmic dance of light and shadow. The Moon's revolution gives us months and phases, while the alignments of these three bodies create spectacular celestial events. Eclipses. Understanding these scientifically helps us appreciate the predictable, rhythmic nature of our universe and frees us from superstition. Thus, the study of the Sun, Moon, and Earth not only deepens our knowledge of geography and astronomy but also reminds us of the harmony and precision of the cosmos. Water Wave. Chapter 3, Tides, Summary. 1000 words, Introduction. When we visit the sea or a coastal region, we often notice that sometimes the sea water comes very close to the shore, and at other times, it moves far away. This regular rise and fall in the level of sea water is called a tide. Tides are among the most fascinating natural phenomena on Earth, directly linked to the gravitational pull of the Moon and the Sun and the rotation of the Earth. This chapter explains how tides occur, the forces responsible for them, their types, timing, and their effects on human life and the environment. 1. What are tides? Tides are the periodic rise and fall of sea water on the Earth's surface. They occur daily and regularly. The sea level rises and covers part of the shore. This is called a high tide. The sea level falls and moves away from the shore. This is called a low tide. A complete cycle of high tide and low tide takes about 12 hours and 25 minutes. Therefore, in 24 hours, most coastal places experience 2 high tides and 2 low tides. 2. The forces responsible for tides. Tides are caused mainly by the gravitational attraction of the Moon and the Sun on the Earth's oceans, combined with the centrifugal force produced by the Earth's rotation. Let's understand both forces. A. Gravitational force. Every object in the universe attracts every other object. The Moon's gravitational pull attracts the water on Earth. Since the Moon is much closer to the Earth than the Sun, its gravitational effect on tides is twice as strong as that of the Sunday. As a result, the part of the Earth facing the Moon experiences a high tide because water is pulled toward the Moon. At the same time, the opposite side of the Earth also experiences a high tide due to the centrifugal force created by the Earth-Moon system. The areas at right angles to these points experience low tides. B. Centrifugal force. As the Earth and Moon revolve around a common center of gravity, a force acts outward on the Earth's oceans. This is the centrifugal force. It acts in the opposite direction to the Moon's gravitational force and causes a second high tide on the opposite side of the Earth. Together, these forces, the Moon's gravitational pull, the Sun's gravitational pull, and the centrifugal force, create 2 bulges of water on opposite sides of the Earth, leading to 2 high tides and 2 low tides each day. 3. Types of tides. The height of the tides varies every day because the relative positions of the Earth, Moon, and Sun keep changing. There are 2 main types of tides. A. Spring tides. These are the highest tides. They occur when the Sun, Moon, and Earth are in a straight line, i.e., on new moon and full moon days. At this time, the gravitational forces of the Sun and Moon combine, producing extra high tides and extra low tides. The term spring refers to the leap or rise of water, not the season. B. Neap tides. These are low or moderate tides. They occur when the Sun and Moon are at right angles, 90 degrees, to the Earth, i.e., during the first and third quarters of the Moon. Their gravitational pulls act in different directions, partially cancelling each other's effect. Hence, the rise of water during high tide is less, and the fall during low tide is also less. Summary: type of tide when it occurs. Description: spring tide, moon, neap tide, full moon and new moon. Highest tides due to combined pull of Sun and first and third quarter. Lowest tides due to opposite pulls of Sun and Moon. 4. Tidal cycle and timing. The time between one high tide and the next is about 12 hours and 25 minutes. Why the extra 25 minutes? Because as the Earth rotates on its axis, the Moon also moves a little along its orbit, about 6 degrees eastward. Thus, it takes extra time for the same point on Earth to again come under the Moon's influence. Therefore, if there is a high tide at 6 a.m., the next high tide will occur around 6:25 p.m. There will also be 2 low tides in between. Thus, every coastal area generally experiences 2 high tides and 2 low tides per day. 5. Difference between waves and tides. Students often confuse tides with waves. Waves are the up and down movement of water caused mainly by wind. Tides are the regular rise and fall of the sea level caused by the gravitational forces of the Moon and Sun. In waves, only the energy moves, but in tides, the whole water level actually rises or falls. 6. Tidal range. The difference in height between a high tide and a low tide is called the tidal range. In the open ocean, the tidal range is small, about 30 centimeters along coasts. It increases to 100-150 cm. The highest tidal range in the world is at the Bay of Fundy, Canada, about 16 meters, 1,600 centimeters. In India, the Gulf of Khambhat has the highest tidal range, about 11 meters, 1,100 centimeters. The tidal range determines how much the coastline is affected by tides and how suitable it is for activities such as ports and tidal energy generation. 7. Importance and effects of tides. Tides have both useful and harmful effects on humans and the environment. A. Positive effects. 1. Navigation and port operations. Tides increase the depth of water at ports, allowing ships to move in and out safely. Without tides, many ports would become too shallow due to sediment deposition. 2. Fishing. Tides help fish and other sea organisms move toward coastal waters, benefiting fishermen. 3. Coastal cleaning. High tides wash away waste and sediments, keeping coastal areas clean. 4. Salt production. Sea water is stored during high tide in salt pans and evaporated to obtain salt. 5. Electricity generation. The movement of water during tides can be harnessed to generate tidal energy. Tidal power stations are built where tidal range is large, e.g., France, UK, South Korea, and Gujarat in India. 6. Biodiversity support. Tides sustain mangroves and coastal ecosystems, which provide shelter for marine life. B. Negative effects. 1. Coastal erosion. Strong tides and waves erode cliffs and beaches. 2. Accidents and drowning. Lack of knowledge about tide timings can cause accidents for swimmers or fishermen. 3. Flooding. Exceptionally high tides during storms can cause storm surges, flooding coastal areas. 8. Relationship between the moon and tides. Tides are more influenced by the moon than the sun because the moon is much closer to Earth, so its gravitational pull is stronger. Therefore, the highest tides occur when the moon is directly above a region or on the opposite side of the Earth. The sun's gravitational force modifies this effect, either strengthening it, spring tide, or weakening it, neap tide. 9. Waves and tsunamis. Extra understanding. While normal tides are regular and predictable, sometimes massive waves called tsunamis occur due to undersea earthquakes or volcanic eruptions. These are not caused by gravitational forces but by sudden movement of water. Tsunamis can reach heights of 10-30 meters near coastal areas and cause massive destruction. Example, the 2004 Indian Ocean tsunami caused by an earthquake near Sumatra, Indonesia, severely affected India's east coast and Sri Lanka. 10. Safety and observation of tides. When visiting beaches or coasts, always check local tide charts or ask local people about high tide timings. Avoid going deep into the sea when tides are rising. Watch for rapid changes in water level. In case of natural disasters like tsunamis, move quickly to higher ground. 11. Activity and observation. The textbook encourages students to visit a nearby coast to observe the rise and fall of tides. Record time intervals between high and low tides. Study how fishermen, boats, and coastal industries depend on tidal cycles. This practical approach helps students connect natural science with real-life applications. 12. Always remember tides occur twice daily due to the combined gravitational pull of the moon and Sunday. The moon has a greater effect because it is closer to Earth. Spring tides equals higher than normal tides. Neap tides equals lower than normal tides. Tidal range equals difference between high and low tide levels. Tides help navigation, fishing, coastal cleaning, and energy generation. 13. Conclusion. Tides are rhythmic movements of the ocean that reflect the powerful influence of celestial bodies on Earth. Though they seem simple, tides demonstrate the deep connection between the Earth, Moon, and Sunday. They play an essential role in coastal life, the marine environment, and human activities. By studying tides scientifically, we not only understand nature better but can also use them sustainably for navigation, clean energy, and protecting coastal ecosystems. Tides, therefore, are more than just the rise and fall of water. They are a vital heartbeat of our planet's oceans. Chapter 4, Air Pressure, Summary 1000 words, Introduction. The air around us has weight, and this weight exerts a pressure on everything on the Earth's surface. This pressure is known as air pressure or atmospheric pressure. Although we cannot see or feel it directly, air pressure affects our weather, winds, rainfall, and even our breathing. This chapter explains what air pressure is, how it is measured, how it changes from place to place, and what effects it produces in the atmosphere. It also introduces students to isobars, pressure belts, and their connection with wind systems. 1. What is air pressure? Air pressure is the weight of air exerted on the Earth's surface. The atmosphere, which extends hundreds of kilometers above us, consists of gases such as nitrogen, oxygen, carbon dioxide, and water vapor. All these gases together have mass and weight, and hence they exert pressure on the surface below. The air column above 1 square centimeter of the Earth's surface weighs about 1 kilogram. On average, the air pressure at sea level is about 1013.25 millibars, MB, or 76 centimeters of mercury, Hg. Thus, even though we don't feel it, a tremendous amount of air pressure acts on our bodies from all sides. The internal pressure of our body balances it, so we don't get crushed. 2. Measurement of air pressure. Air pressure is measured using an instrument called a barometer. There are mainly two types: A. Mercury barometer, invented by Evangelista Torricelli in 1643. It consists of a glass tube filled with mercury inverted in a mercury container. The height of mercury column changes with air pressure. At sea level, the height is 76 centimeters, 760 millimeters. This is taken as the standard pressure. B. Aneroid barometer. It has no liquid mercury. It uses a metal box that expands or contracts with changes in air pressure. The movement of the box operates a needle on a dial, showing the pressure reading in millibars. Aneroid barometers are commonly used in weather stations, airplanes, and ships because they are portable and safe. 3. Units of air pressure. Air pressure can be expressed in millibars, MB, most commonly used unit. Centimeters or inches of mercury, cm/in Hg, in older systems. At sea level, 76 centimeters or 29.92 inches of Hg equals 1013.25 mb4. Factors affecting air pressure. Air pressure is not uniform everywhere. It changes from place to place and time to time due to several factors. A. Altitude. Height above sea level, air pressure decreases with increasing altitude because the higher we go, the thinner the air becomes. At sea level, air pressure is highest. On mountains, air pressure is much lower. For example, at 5,500 meters, Mount Kilimanjaro, air pressure is only about half that of sea level. This is why mountaineers and pilots carry oxygen cylinders. The air is thinner and pressure is low at higher altitudes. B. Temperature. When air becomes warm, it expands and becomes lighter, creating a low-pressure area. When air becomes cold, it contracts and becomes heavier, creating a high-pressure area. Thus, high temperature, low pressure, low temperature, high pressure. For example, during summer, India's landmass gets heated, creating low pressure. During winter, it cools and creates high pressure. C. Water vapor. Humidity. Moist air, air with more water vapor, is lighter than dry air. So, when humidity increases, the air pressure decreases. That's why humid coastal areas often have lower air pressure than dry desert regions. 5. Distribution of air pressure on Earth. Air pressure across the Earth is not uniform. It is arranged in pressure belts running parallel to the equator due to differences in temperature, rotation of the Earth, and uneven distribution of land and water. There are 7 main pressure belts. A. Equatorial low pressure belt, 0 degrees 5 degrees north and S. The sun's rays fall vertically near the equator, heating the air intensely. Warm air rises, creating a low pressure zone. It is also known as the doldrums because winds here are calm. B. Subtropical high pressure belts, 30 degrees north and S. The warm air from the equator rises and spreads toward the poles. It cools and descends at about 30 degrees latitude, creating high pressure zones. Known as the horse latitudes, regions of calm winds and dry climate, like deserts. C. Subpolar low pressure belts, 60 degrees north and S. Cold polar air meets warmer tropical air, causing the warm air to rise and form low pressure zones around 60 degrees latitudes. D. Polar high pressure belts, 90 degrees north and S. Extremely cold regions with dense, heavy air exert high pressure. Air moves outward from the poles toward lower latitudes. Thus, Alternating high and low pressure belts are formed across the globe. 6. Isobars. On weather maps, air pressure is shown using lines called isobars. An isobar is a line connecting places having equal air pressure. They are drawn at regular pressure intervals, e.g., 1000 mb, 1004 mb, 1008 mb. The pattern of isobars helps meteorologists identify high and low pressure areas and predict wind directions. Interpretation: when isobars are close together, the pressure difference, gradient, is high, indicating strong winds. When they are far apart, winds are light. 7. Pressure gradient and wind. Air always moves from high pressure areas to low pressure areas. The difference in pressure between two places is called the pressure gradient. Steep gradient fast winds, gentle gradient slow winds. This movement of air due to pressure difference gives rise to winds, which are studied in the next chapter. Thus, air pressure plays a crucial role in controlling global wind systems and weather patterns. 8. Variation of pressure over time. Air pressure also changes with time, daily changes, due to heating and cooling during the day and night. Seasonal changes, due to shifting of the sun between the tropics of Cancer and Capricorn. For example, in summer, continental regions like India develop low pressure due to high heat. In winter, they develop high pressure as the air cools down. This seasonal shift leads to phenomena like the monsoon winds. 9. Air pressure and weather. Changes in air pressure are closely related to changes in weather. A fall in air pressure usually indicates stormy or rainy weather. A rise in air pressure indicates clear and dry weather. Therefore, barometers are essential tools in weather forecasting. Examples: cyclones, low pressure, bring strong winds and rain. Anticyclones, high pressure, bring calm and dry weather. 10. Practical applications of air pressure. 1. Aviation. Air pressure helps determine flight altitude. Airplanes fly at levels where pressure is stable. 2. Meteorology, predicting rainfall, storms, and temperature changes. 3. Human physiology, understanding why breathing becomes difficult at high altitudes. 4. Engineering, designing of pressure-based instruments like barometers, pumps, and weather balloons. 11. Activity and observation. The textbook encourages learners to perform small observations, note weather conditions when barometer readings fall or rise. Observe how pressure changes with altitude while traveling in hills or mountains. Watch weather reports to see how pressure maps are used for forecasting. 12. Important facts to remember. Air pressure equals weight of air per unit area. Measured by barometer in millibars, MB. Average sea level pressure equals 1013.25 mb or 76 centimeters of Hg. Decreases with altitude and rises with fall in temperature. High temperature low pressure, low temperature high pressure. Isobars connect places with equal pressure. Air moves from high pressure to low pressure, creating winds. 13. Summary of pressure belts and winds. Pressure belt. Nature. Latitude, approximate, type of wind produced. Equatorial, subtropical, subpolar, polar. High low 0 degrees doldrums, calm, high 30 degrees N/S. Trade winds. Low 60 degrees N/S. Westerlies 90 degrees N/S. Polar easterlies. These belts and winds together form the global circulation system that determines the Earth's climate. 14. Conclusion. Air pressure may be invisible, but it governs many visible processes around us, from breezes and storms to rainfall and climate zones. It is one of the most important elements of weather and helps maintain balance in the atmosphere. By studying air pressure, we understand how the Earth's rotation, temperature, and altitude combine to shape global patterns of wind and weather. Thus, air pressure acts as the driving force of the atmosphere, linking all meteorological processes in one continuous cycle. Chapter 5, Winds, Summary. 1000 words. Introduction. The movement of air is one of the most important natural processes on Earth. The continuous flow of air across the surface of the Earth is called wind. Winds play a key role in determining weather and climate, distributing heat and moisture, and even shaping landforms. This chapter explains what causes winds, their types, directions, and their role in weather systems such as cyclones and monsoons. It also links the concept of air pressure, from the previous chapter, with the movement of air. 1. What is wind? Wind is the horizontal movement of air from areas of high pressure to areas of low pressure. Air moves because of differences in temperature and pressure. The greater the difference, the faster the wind blows. If the pressure difference is high, wind speed is strong. If the pressure difference is low, wind speed is gentle. Wind helps in balancing temperature and pressure differences across the globe and keeps the atmosphere dynamic. 2. Relation between temperature, pressure, and wind. The main cause of wind is the unequal heating of the Earth's surface. When the sun heats the Earth, warm air expands and rises, creating a low-pressure area. Cool air from nearby high-pressure areas moves in to replace it. This movement of air from high to low pressure is called wind. Thus, temperature differences, pressure differences, winds. For example, during daytime, land heats up faster than the sea. Low pressure forms over land, and air from the sea flows toward the land, sea breeze. At night, the opposite happens. Land cools faster, high pressure forms over land, and air flows from land to sea, land breeze. 3. Forces affecting wind movement. There are three main forces that control the movement and direction of winds. A. Pressure gradient force. It is the difference in pressure between two areas. Wind blows from high pressure areas to low pressure areas. The greater the pressure difference, the stronger the wind. B. Coriolis force. Because the Earth rotates from west to east, moving air appears to deflect, to the right in the northern hemisphere, to the left in the southern hemisphere. This deflection is called the Coriolis effect. It causes the winds to move in curved paths instead of straight lines. C. Frictional force. Near the Earth's surface, mountains, trees, and buildings create friction that slows down the wind and changes its direction slightly. At higher altitudes, friction is minimal, and winds blow more freely. 4. Measurement of wind. Winds are measured in two main aspects: direction measured using a wind vane. The arrow points in the direction from which the wind is blowing, e.g., a north wind blows from the north. Speed measured using an anemometer. It records how fast the wind is moving, usually in kilometers per hour, km/h. Meteorologists use these instruments in weather stations to record daily wind patterns. 5. Types of winds. Based on their nature and time of occurrence, winds are classified into three main types: 1. Permanent, planetary, winds. 2. Periodic winds. 3. Local winds. Let's understand each type. 6. Permanent, planetary, winds. These are constant winds that blow regularly throughout the year in fixed directions. They are caused by the global pattern of pressure belts and the Earth's rotation. There are three main types of permanent winds. A. Trade winds blow from subtropical high-pressure belts, 30 degrees N/S, toward the equatorial low-pressure belt, 0 degrees. Due to the Coriolis effect, they are deflected: northeast trade winds in the northern hemisphere, southeast trade winds in the southern hemisphere. These winds are steady and regular and bring rain to coastal tropical regions. Example: trade winds bring rainfall to the northeast coast of South America and Southeast Asia. B. Westerlies blow from subtropical high-pressure belts, 30 degrees N/S, toward subpolar low-pressure belts, 60 degrees N/S. In the northern hemisphere, they blow from southwest to northeast. In the southern hemisphere, from northwest to southeast. They are responsible for much of the weather in Europe, North America, and southern Australia. C. Polar easterlies blow from polar high-pressure areas, 90 degrees N/S, toward subpolar low-pressure belts, 60 degrees N/S. They are cold and dry winds, blowing from the east in both hemispheres. They influence weather in polar and subpolar regions. These three wind systems together maintain a continuous global circulation of air. 7. Periodic winds. These winds change direction periodically with seasons or time of day due to variations in heating and cooling. A. Monsoon winds. The word monsoon means season in Arabic. Monsoons are seasonal winds that reverse direction twice a year. They blow due to the difference in temperature and pressure between land and sea. In summer, the land gets heated more than the sea. Low pressure develops over land, especially in India, and moist air from the ocean flows toward the land, bringing heavy rainfall, southwest monsoon. In winter, the land cools down faster than the sea. High pressure develops over land, and air flows from land to sea, northeast monsoon, bringing dry weather. Thus, monsoons cause distinct wet and dry seasons, especially in tropical countries like India, Myanmar, Thailand, and Indonesia. B. Land and sea breezes. These are daily periodic winds near coastal areas. Daytime, sea breeze. The land heats up faster, forming low pressure, cooler air from the sea flows toward the land. Nighttime, land breeze. The land cools faster, high pressure forms on land, and air flows from land to sea. These breezes regulate the temperature of coastal regions and make them more comfortable. C. Mountain and valley breezes. These occur in hilly areas. Daytime, valley breeze. The slopes of mountains get heated, air rises, and cooler air from the valley moves up. Nighttime, mountain breeze. The slopes cool quickly, cold air descends into the valley. Such winds influence local weather and temperature in mountainous regions. 8. Local winds. Local winds blow over small areas for short durations due to local temperature differences. Some examples include, wind name region characteristic Lu northern India very hot and dry wind in summer Chinook Rocky Mountains, North America, warm, dry wind that melts snow Fain Alps, Europe, warm, dry wind that aids farming Mistral France cold wind blowing from mountains to Mediterranean coast Sirocco Sahara Desert to southern Europe hot, dusty wind Bora Adriatic coast cold, dry wind Local winds affect agriculture, temperature, and living conditions of the regions where they occur. 9. Cyclones and anticyclones. Winds also form circular systems known as cyclones and anticyclones. A. Cyclones are low-pressure systems with inward spiraling winds. Winds move anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. Bring heavy rainfall, strong winds, and sometimes destruction. Examples, Cyclone Amphan, Tauktai, India. B. Anticyclones are high-pressure systems with outward spiraling winds. Bring clear skies and dry weather. Winds move in the opposite direction of cyclones. Cyclones are vital for rainfall but can also cause severe damage to life and property. 10. Importance of winds. Winds have a great impact on nature and human life. A. Positive effects. 1. Distribution of heat and moisture. Winds transfer heat from equatorial to polar regions, balancing global temperature. 2. Rainfall. Monsoon and trade winds bring rainfall to many parts of the world. 3. Navigation. In earlier times, sailing ships depended on trade winds for ocean travel. 4. Energy. Modern wind turbines convert wind energy into electricity. 5. Pollination and seed dispersal. Winds help plants reproduce and spread. B. Negative effects. 1. Storms and cyclones. Strong winds can cause destruction to property and crops. 2. Desertification. Hot, dry winds can erode fertile soil and turn land barren. 11. Observation and experiment. The textbook encourages observing local wind patterns, such as direction of wind at different times of day. How flags, smoke, or trees indicate wind direction. Using a simple wind vane or paper arrow to study wind movement. Such activities help students understand how winds influence daily weather. 12. Key points to remember. Wind equals movement of air from high pressure to low pressure, caused by unequal heating of the earth, controlled by pressure gradient, Coriolis effect, and friction, measured by wind vane, direction, and anemometer, speed. 3 types, 1. Permanent, trade, westerlies, polar easterlies. 2. Periodic, monsoon, land, and sea breezes. 3. Local, Lu, Chinook, Fein, etc. Winds distribute heat, bring rainfall, and influence weather. 13. Conclusion. Winds are the lifeblood of the atmosphere. They balance temperature and pressure, bring rains, and influence the world's climate. From gentle breezes to fierce cyclones, winds are a powerful force shaping our environment. Understanding winds helps us predict weather, protect lives from storms, and harness wind power for sustainable energy. Thus, winds are not just moving air, they are a vital link between the sun's heat, Earth's rotation, and life itself. Chapter 6, Natural Regions, Summary 1000 words, Introduction. The surface of the Earth is vast and diverse. Some regions are hot and wet, others cold and dry, some covered with forests, and others with deserts or grasslands. These differences arise due to variations in climate, temperature, rainfall, soil, vegetation, and human lifestyle. To study such large-scale similarities and differences, geographers divide the world into areas called natural regions. A natural region is an area where the climate, natural vegetation, wildlife, and human occupations are broadly similar. This chapter explains how these regions are classified, the basis for their division, and the major types of natural regions found on Earth. 1. What is a natural region? A natural region is a part of the Earth's surface that has its own distinct set of climatic conditions, vegetation, wildlife, and human activities. In other words, it is a region where all natural features are related to one another and form a unique environment. For example, the equatorial region has high temperature, heavy rainfall, dense forests, and people engaged mainly in hunting, gathering, and forestry. The desert region has little rainfall, sparse vegetation, and occupations like camel rearing or oasis farming. 2. Basis of classification of natural regions. Geographers use several factors to divide the world into natural regions. The most important among them are, a. Latitude and temperature. Temperature varies mainly with latitude. Near the equator, low latitudes, very hot regions. Near the poles, high latitudes, very cold regions. Between them, moderate or temperate regions. Thus, latitude helps define broad climatic zones: tropical, temperate, and polar. B. Rainfall. The amount and distribution of rainfall strongly influence the type of vegetation and human life. Heavy rainfall, dense forests; moderate rainfall, grasslands. Very little rainfall, deserts. C. Relief, landform, mountains, plateaus, and plains affect temperature, rainfall, and vegetation. For instance, mountainous regions are cooler and wetter than nearby plains. D. Vegetation and wildlife. Different climates support different vegetation types, forests, grasslands, tundra, etc., which in turn support specific animals. E. Human activities. People adapt to their environment. Their clothing, food, and occupations, like farming, herding, fishing, depend on the natural conditions. Based on these interrelated factors, the world is divided into major natural regions. 3. Major natural regions of the world. Geographers commonly recognize the following main natural regions: 1. Equatorial region. 2. Tropical grasslands. 3. Tropical deserts. 4. Mediterranean region. 5. Temperate grasslands. 6. Temperate forests. 7. Taiga or coniferous forests. 8. Tundra or polar region. Each region has distinctive climate, vegetation, and human life, as described below. 4. The equatorial region. Palm tree location, found on both sides of the equator, 0 degree 10 degree NNS. Examples: Amazon Basin, South America, Congo Basin, Africa, Indonesia, Malaysia. Climate: hot and wet throughout the year. Average temperature, around 27 degrees C 30 degrees C. Rainfall, more than 200 centimeters per year, almost daily showers. Vegetation, dense tropical rainforests, evergreen forests. Trees grow tall, up to 50 m, and form thick canopies. Important trees: mahogany, ebony, rosewood, rubber, coconut, bamboo. Wildlife: monkeys, snakes, parrots, leopards, gorillas, elephants, crocodiles, and numerous insects. Human life: difficult living conditions due to thick forests and humidity. People practice shifting cultivation, hunting, and gathering forest products, rubber, timber, fruits. Forests are being cleared for plantations of cocoa, coffee, and oil palm. 5. Tropical grasslands, savanna, year of rice location, between 10°-20° latitudes in both hemispheres. Examples: East Africa, Kenya, Tanzania, parts of Brazil, and northern Australia. Climate: distinct wet and dry seasons. Rainfall: about 75–125 cm annually. High temperature throughout the year. Vegetation: grass grows tall, 3–4 meters, with scattered trees like acacia and baobab. Known as savanna in Africa, campos in Brazil, and llanos in Venezuela. Wildlife: lions, elephants, giraffes, zebras, deer, and cheetahs. Human life: people engaged in cattle rearing and farming. Grasslands provide excellent grazing land called the home of wild animals. 6. Tropical deserts location, around 20°–30° latitudes in both hemispheres. Examples: Sahara, Africa, Arabian Desert, Dar, India, Australian Desert. Climate: very hot and dry throughout the year. Temperature: up to 50 degrees Celsius during the day, cold nights. Rainfall: less than 25 centimeters annually. Vegetation: very sparse, only drought-resistant plants like cactus, date palm, acacia. Wildlife: camels, snakes, lizards, and scorpions. Human life: nomadic tribes like Bedouins and Tuaregs rear camels and sheep. Oases are centers of life: date palms and vegetables grown there. Modern development includes oil extraction and tourism. 7. Mediterranean region grapes location, around 30°–40° latitudes on western coasts of continents. Examples: coastal regions around the Mediterranean Sea, California, USA, central Chile, South Africa, and southwest Australia. Climate: hot, dry summers and cool, rainy winters. Rainfall: about 75–100 cm, mostly in winter. Pleasant climate often called the Garden of the World. Vegetation: evergreen shrubs and small trees with thick leaves. Common plants: olive, cork, orange, lemon, vine, grape, and fig. Wildlife: animals adapted to dry summers: rabbits, foxes, reptiles, and birds. Human life: ideal for farming and tourism. People practice orchard farming and viticulture, grape cultivation. Mediterranean countries export olive oil, wine, and citrus fruits. 8. Temperate grasslands year of rice location, found in the interior parts of continents between 30°–55° latitudes. Examples: prairies, North America, pampas, South America, steppes, Eurasia, downs, Australia, and velds, South Africa. Climate: moderate rainfall, 25–75 cm. Summers are warm, winters are cold. Vegetation: grass dominates due to insufficient rainfall for trees. Very fertile soil ideal for grain cultivation. Wildlife: herbivores like deer, bison, antelope, and wolves. Human life: known as the granaries of the world due to large-scale wheat and maize farming. Modern agriculture and cattle ranching are major occupations. 9. Temperate forests location, between 40°–60° latitudes in both hemispheres. Examples: eastern North America, western Europe, parts of China, Japan, and New Zealand. Climate, moderate and well-distributed rainfall, 100–150 cm. Distinct seasons: warm summers, cold winters. Vegetation, deciduous trees like oak, maple, beech, birch. Trees shed leaves in winter. Wildlife, bears, deer, foxes, and birds. Human life, developed regions with industrial and agricultural activities. Forests used for timber and paper industries. 10. Taiga or coniferous forest region. Snowflake location, between 55°–70° latitudes, south of the tundra. Examples: Canada, Russia, Scandinavia. Climate, very cold with long winters and short summers. Rainfall, moderate, mostly as snow. Vegetation, coniferous trees with needle-shaped leaves, pine, fir, spruce. Forests are called softwood forests used in paper and furniture industries. Wildlife, bears, wolves, foxes, and fur-bearing animals. Human life, sparse population. Main occupation, lumbering and fur trading. 11. Tundra or polar region. Snowflake location, beyond 70° latitudes near the poles, Arctic and Antarctic. Examples: northern Canada, Greenland, Siberia, Antarctica. Climate, extremely cold, long winters, and short cool summers. Temperature mostly below 0°C. Very little rainfall, as snow. Vegetation, almost no trees, only mosses, lichens, and small shrubs grow in summer. Wildlife, polar bears, seals, reindeer, Arctic foxes. Human life, inhabitants include Inuits, Eskimos, who hunt and fish. Houses made of snow, igloos. Now, oil and mineral exploration is developing the region. 12. Importance of natural regions. Help us understand how climate affects vegetation, animals, and human life. Useful for studying agriculture, population, and resource use. Aid in planning development suited to environmental conditions. Help identify areas prone to natural disasters and climate change impacts. 13. Summary table. Region climate, vegetation, human life, equatorial hot and wet, dense evergreen forests, shifting cultivation, forestry, tropical grasslands, hot with wet and dry seasons, tall grasses, scattered trees, cattle rearing, desert, hot and dry, sparse cactus, shrubs, nomadic herding, oasis farming, Mediterranean, hot dry summers, mild winters, olive, vine, citrus farming, tourism, temperate grasslands, moderate rainfall, short grasses, wheat farming, temperate forests, moderate rainfall, 4 seasons. Deciduous forests, industry, farming, taiga, cold, snowy coniferous forests, lumbering, tundra, extremely cold, mosses, lichens, hunting, fishing. 14. Conclusion. Natural regions show the beautiful interrelationship between nature and human life. Climate determines vegetation, which influences animal life and human occupation. Each region, from the lush equatorial forests to the icy tundra, has its own distinct identity and way of life. Understanding natural regions helps us appreciate the diversity of the earth and use its resources wisely while maintaining the balance of nature. Seedling. Chapter 7, Soils, Summary. 1000 words, Introduction. Soil is one of the most valuable natural resources on Earth. It forms the uppermost layer of the Earth's crust and supports all forms of terrestrial life, plants, animals, and humans. Every plant that we eat or use grows in soil, and almost all human activities, such as agriculture, construction, and forestry, depend on it. This chapter explains how soil forms, its composition, types, distribution, and the importance of soil conservation. 1. What is soil? Soil is the thin layer of loose material covering the surface of the earth in which plants grow. It consists of minerals, organic matter, air, water, and living organisms. It forms the basis of agriculture and is vital for maintaining ecological balance. Soil acts as a storehouse of nutrients for plants, a filter that purifies water, A habitat for many organisms like earthworms, insects, and microbes. 2. Composition of soil. Soil is made up of 5 main components. 1. Mineral matter, 45%. Derived from the parent rock. Contains sand, silt, and clay particles. 2. Organic matter, humus, 5%. Formed from decomposed plants and animals. Improves soil fertility and water retention. 3. Water, 25%. Present in soil pores, helps dissolve minerals and nutrients. 4. Air, 25%. Fills spaces between soil particles, provides oxygen to roots and soil organisms. 5. Living organisms. Bacteria, fungi, earthworms, and insects that help in decomposition and nutrient cycling. The exact proportion varies depending on the type and location of the soil. 3. Formation of soil. Soil formation or pedogenesis. Soil formation is a slow, natural process that takes thousands of years. It begins with the weathering of rocks, which breaks them into smaller particles, and continues with biological and chemical processes that enrich the soil. The major processes involved are: 1. Weathering of rocks. Physical, chemical, and biological weathering breaks rocks into fine particles. 2. Addition of organic matter. Dead plants and animals decompose and form humus, enriching the soil. 3. Mixing by organisms. Earthworms, ants, and microbes mix organic matter with mineral particles. 4. Leaching and accumulation. Rainwater dissolves minerals and carries them downward, leaching. Accumulation of minerals forms distinct soil layers. This gradual combination of rock material and organic matter creates fertile soil. 4. Soil profile, layers of soil. A soil profile is a vertical section of soil showing different layers, called horizons. 1. A horizon, topsoil, uppermost layer, rich in humus and nutrients. Dark in color and fertile. Most plant roots grow here. 2. B horizon, subsoil, below the topsoil, contains minerals leached from above. Less humus and lighter in color. 3. C horizon, weathered rock, made of partially weathered parent rock material. 4. R horizon, bedrock, the unweathered solid rock layer beneath all others. The thickness of these layers varies from place to place depending on the climate, rock type, and time. 5. Factors affecting soil formation. Several natural factors influence how and where soils form. 1. Parent rock, determines the soil's texture and mineral composition. Example, granite forms sandy soil, basalt forms black clayey soil. 2. Climate, temperature and rainfall affect weathering and organic decomposition. Warm, wet climates produce thick, fertile soils, dry climates produce thin, poor soils. 3. Relief, slope of land. Flat areas allow thick soil formation. Steep slopes lose soil due to erosion. 4. Living organisms, plants add organic matter, animals and microbes mix and enrich the soil. 5. Time, soil formation is slow. It can take hundreds to thousands of years for 1 inch of soil to form. 6. Major types of soils in India. India's diverse climate and geology have led to several soil types. The main types are: A. Alluvial soil found in the plains of the Ganga, Indus, and Brahmaputra. Formed by river deposits. Very fertile, rich in potash and lime. Ideal for crops like wheat, rice, sugarcane, and pulses. Occupies about 40% of India's land area. B. Black soil, Regur soil, found in Deccan Plateau, Maharashtra, Gujarat, Madhya Pradesh. Formed from lava rocks, basalt. Rich in iron, lime, and alumina. Retains moisture, ideal for cotton cultivation. Also used for growing soybean, jowar, and sugarcane. C. Red soil found in Tamil Nadu, Karnataka, Odisha, Jharkhand, and Chhattisgarh. Derived from crystalline and metamorphic rocks. Red color due to iron oxide. Poor in nitrogen and humus, needs fertilizers for cultivation. D. laterite soil found in western Ghats, Meghalaya, Kerala, and parts of Odisha. Formed in high rainfall, high temperature regions. Leaching removes nutrients, so not very fertile. Suitable for tea, coffee, and cashew with proper manure. E. Arid, desert, soil found in Rajasthan and Gujarat. Sandy and saline, with low water retention. Poor in humus but can be made fertile by irrigation. Crops, millets, bajra, barley, and maize. F. Mountain soil found in Himalayan regions. Thin, immature soil formed by weathering of rocks. Fertile in valleys, supports tea, apple, and plantation crops. 7. Importance of soil. Soil is essential for both natural and human life. 1. Supports plant growth, provides nutrients and water. 2. Source of minerals, contains essential elements for agriculture and industries. 3. Habitat for organisms, microorganisms, insects, and worms live and recycle nutrients. 4. Regulates water flow, stores rainwater and filters it. 5. Foundation for human activities, supports houses, roads, and industries. Without healthy soil, there can be no sustainable agriculture or ecosystem balance. 8. Soil erosion. Soil erosion is the removal of the top fertile layer of soil by natural forces such as wind and water, or by human activities. Causes of soil erosion. 1. Deforestation, cutting of trees removes protective cover. 2. Overgrazing by animals. 3. Unscientific farming, plowing on slopes, over-irrigation. 4. Heavy rainfall and floods. 5. Strong winds in dry areas. Effects of soil erosion: loss of fertility and crop yield. Formation of gullies and ravines. Desertification of land. Flooding and siltation of rivers. 9. Soil conservation. Soil conservation means protecting soil from erosion and maintaining its fertility for future use. Methods of soil conservation. 1. Afforestation, planting trees to hold the soil with roots. 2. Contour plowing, plowing across the slope to reduce runoff. 3. Terrace farming, cutting hill slopes into steps to slow water flow. 4. Windbreaks and shelter belts, planting trees in rows to reduce wind speed. 5. Crop rotation, growing different crops alternately to maintain soil nutrients. 6. Use of organic manure, adds humus and improves soil structure. 7. Check dams, prevent gully formation and soil loss. Conservation ensures long-term productivity and ecological balance. 10. Soil and human life. Human life is directly dependent on soil. Farmers depend on soil fertility for their livelihood. Industries like pottery, brickmaking, and construction use soil as raw material. Soil supports forests, which in turn influence climate, water, and oxygen. Hence, protecting soil means protecting life itself. 11. Key facts to remember: soil equals mixture of minerals, humus, air, and water. Soil formation takes thousands of years. Soil profile has A, B, C, and R horizons. Major soil types in India: alluvial, black, red, laterite, arid, mountain. Soil erosion equals loss of fertile topsoil. Conservation equals afforestation, contour plowing, terrace farming, etc. 12. Conclusion: soil is the foundation of terrestrial life. It grows our food, supports our homes, and sustains ecosystems. However, careless human activities like deforestation and overuse of chemicals are degrading this precious resource. Protecting and conserving soil through scientific farming, afforestation, and sustainable practices is essential for ensuring food security and environmental health. As the saying goes, to forget how to dig the earth and tend the soil is to forget ourselves. Chapter 8, How Seasons Occur Part 2, Summary 1000 words, Introduction. In the first part of this topic, we learned that seasons occur due to the Earth's revolution around the Sun and the tilt of its axis. The tilt, 23½ degree, causes different parts of the Earth to receive varying amounts of sunlight throughout the year. In this second part, we explore how these factors produce the four main seasons: summer, winter, spring, and autumn in both hemispheres. We also learn about solstices, equinoxes, and how the duration of day and night changes with the seasons. 1. The Earth's tilt and revolution. The Earth's axis is tilted at 23½ degree from the perpendicular to the plane of its orbit. As the Earth revolves around the Sun, this tilt remains constant and parallel to itself throughout the year. This means, the North Pole always points toward the North Star, Polaris. Because of this tilt, the Sun's rays fall vertically at different latitudes at different times of the year. This variation causes seasonal changes in temperature, length of day and night, and intensity of sunlight. Thus, the combination of tilt and revolution is the main cause of the changing seasons. 2. The apparent movement of the Sun. To an observer on Earth, the Sun appears to move north and south between the Tropic of Cancer, 23½ degree N, and the Tropic of Capricorn, 23½ degree S, during the year. This apparent movement leads to the changing position of sunrise and sunset on the horizon and marks the shift of seasons. Around June 21st, the Sun is overhead at the Tropic of Cancer. Around December 22nd, the Sun is overhead at the Tropic of Capricorn. On March 21st and September 23rd, the Sun is overhead at the equator. These 4 dates mark important turning points in the Earth's yearly cycle: solstices and equinoxes. 3. Solstices and equinoxes. The terms solstice and equinox come from Latin words meaning sun standing still and equal night, respectively. A. Summer solstice. Around June 21st, the North Pole is tilted toward the Sunday. The Sun's vertical rays fall on the Tropic of Cancer, 23½ degree N. The Northern Hemisphere receives maximum sunlight and experiences summer. The day is longest and night is shortest in the Northern Hemisphere. The Southern Hemisphere is tilted away and experiences winter with short days and long nights. B. Winter solstice. Around December 22nd, the South Pole is tilted toward the Sunday. The Sun's vertical rays fall on the Tropic of Capricorn, 23½ degree S. The Southern Hemisphere receives more sunlight. It is summer there. The Northern Hemisphere receives less sunlight and experiences winter. The day is shortest and night is longest in the Northern Hemisphere. C. Vernal equinox. Around March 21st, the Sun's rays fall directly on the equator. Both hemispheres receive equal sunlight. Day and night are equal everywhere. Marks spring in the Northern Hemisphere and autumn in the Southern Hemisphere. D. Autumnal equinox. Around September 23rd, again, the Sun's rays are vertical at the equator. Day and night are equal all over the Earth. Marks autumn in the Northern Hemisphere and spring in the Southern Hemisphere. Thus, the solstices and equinoxes divide the year into 4 distinct seasons. 4. The 4 seasons. The revolution of the Earth creates 4 major seasons: summer, autumn, winter, and spring, which repeat each year. Their timing is opposite in the 2 hemispheres. Season: Northern Hemisphere, Southern Hemisphere. Sun's position: summer June to August, December to February, Tropic of Cancer; autumn September to November, March to May, equator, September 23rd, winter December to February, June to August, Tropic of Capricorn; spring March to May, September to November, equator, March 21st. Let's look at these in detail. 5. Summer: when? June to August in the Northern Hemisphere, December to February in the Southern Hemisphere. Reason: the hemisphere is tilted toward the Sun and gets direct rays. Day length: long days and short nights. Weather: hot and bright, sometimes dry. Examples: India experiences summer in May-June. Australia experiences summer in December-January. Effects: high temperature accelerates plant growth. Glaciers melt and rivers flow more strongly. People wear light cotton clothes and use fans or air conditioners. 6. Autumn: when? September to November in the Northern Hemisphere, March to May in the Southern Hemisphere. Reason: the Sun gradually moves from the Tropic of Cancer toward the equator. Day length: days and nights become almost equal. Weather: moderate and pleasant. Examples: trees shed their leaves to conserve moisture. In India, this is the post-monsoon period. Effects: preparation for winter begins in nature. Harvesting of crops like rice and maize occurs. 7. Winter when? December to February in the northern hemisphere, June to August in the southern hemisphere. Reason: the hemisphere is tilted away from the sun, so sunlight is slanting and less intense. Day length: short days and long nights. Weather: cold, often snowy in temperate regions. Examples: India's winter is from December to February. South Africa's winter is from June to August. Effects: vegetation growth slows. Animals hibernate in cold areas. People wear woolen clothes and use heating devices. 8. Spring when? March to May in the northern hemisphere, September to November in the southern hemisphere. Reason: the sun moves from the equator toward the Tropic of Cancer. Day length: days and nights are equal at first but days become longer gradually. Weather: mild, neither too hot nor too cold, considered the most pleasant season. Examples: flowers bloom, new leaves appear. Farmers sow crops for the next harvest. Effects: known as the season of renewal. Encourages agricultural and biological activity. 9. Seasonal differences between hemispheres. Because of the Earth's tilt, seasons are opposite in the two hemispheres. When it is summer in India, northern hemisphere, it is winter in Australia, southern hemisphere. When it is spring in the northern hemisphere, it is autumn in the southern hemisphere. This happens because while one hemisphere is tilted toward the sun, the other is tilted away from it. 10. Effect of seasons on day and night. The duration of day and night varies with the season and latitude. Near the equator, day and night are almost equal throughout the year. Toward the poles, the difference becomes extreme. At the Arctic Circle, 66½ degree N, during the summer solstice, the sun never sets, known as the midnight Sunday. During the winter solstice, the region remains dark all day, known as polar night. Thus, the tilt of the Earth not only causes seasons but also changes in length of daylight. 11. How seasons affect life on Earth. The rhythm of seasons influences all forms of life. A. Human activities. Agriculture depends on seasonal changes in temperature and rainfall. Festivals, clothing, and lifestyles change with seasons. Tourism industries thrive in seasonal climates, e.g., winter sports or beach holidays. B. Plants adapt to seasonal light and temperature. Deciduous trees shed leaves in autumn and regrow them in spring. C. Animals. Some animals hibernate during cold seasons, others migrate to warmer areas. Birds migrate to take advantage of seasonal food and breeding conditions. D. Environment. Seasonal melting of snow refills rivers and lakes. Rainfall cycles sustain ecosystems and groundwater. 12. Summary of key points. Event date, approximate, sun's position, northern hemisphere, southern hemisphere, summer solstice day, winter autumnal equinox, winter solstice, summer June 21, Tropic of Cancer, longest day, summer shortest Sep 23, equator autumn spring Dis 22, Tropic of Capricorn, shortest day, winter longest day, vernal equinox Mar 21, equator spring autumn. Main reasons for seasons: 1. Revolution of the Earth around a Sunday. 2. Tilt of the Earth's axis, 23½ degree. 3. Parallelism of the axis during revolution. Effects: variation in temperature, rainfall, and vegetation. Unequal duration of day and night. Opposite seasons in opposite hemispheres. 13. Observation and activity. Students are encouraged to observe sunrise and sunset directions in different months. Note changes in day length. Track how the sun's position changes between summer and winter using a stick's shadow. These simple observations make seasonal changes visible and understandable. 14. Conclusion. The Earth's tilted axis and revolution create the wonderful rhythm of seasons, from the heat of summer to the chill of winter, from the bloom of spring to the calm of autumn. These changes not only affect temperature and light but also shape ecosystems, agriculture, and human culture. Understanding how seasons occur helps us appreciate the balance of nature and the predictable harmony of the solar system. In short, the changing seasons remind us that Earth is alive, moving, tilting, revolving, and sustaining all life through its eternal dance around the sun. Year of Rice Chapter 9, Agriculture, Summary 1000 words, Introduction. Agriculture is one of the oldest and most essential human activities. It involves the cultivation of land to grow crops and the rearing of animals to provide food, clothing, and other necessities. Agriculture is the backbone of human civilization. It supports life, economy, and employment. This chapter explains the meaning of agriculture, the factors affecting it, its types, and how it differs in various regions of the world. It also highlights the importance of agriculture in India and the need for modernization and sustainability. 1. What is agriculture? The word agriculture is derived from the Latin words ager, field, and culture, cultivation. It means the science and art of cultivating the land and rearing animals to produce food and other useful materials. Agriculture includes growing crops, grains, fruits, vegetables, animal husbandry, forestry and fisheries, dairy and poultry farming. It forms the primary sector of the economy, as all other sectors depend directly or indirectly on it. 2. Importance of agriculture. 1. Food supply, provides food, grains, fruits, and vegetables for human consumption. 2. Employment, employs more than half of the world's population, especially in developing countries. 3. Raw materials, supplies materials for industries, cotton, jute, sugarcane, etc. 4. Trade and economy, agricultural exports earn foreign exchange. 5. Livelihood, supports millions of farmers and rural workers. 6. Environmental balance, maintains greenery, absorbs carbon dioxide, and helps prevent soil erosion. Thus, agriculture is not only an economic activity but also a vital ecological process. 3. Factors affecting agriculture. Agriculture depends on both natural and human factors. A. Natural factors. 1. Climate, temperature and rainfall determine which crops can grow. Rice needs hot, wet climates, wheat needs cool, dry climates. 2. Soil, fertile alluvial soil supports intensive farming. Sandy or stony soils limit cultivation. 3. Relief, topography, plains and river valleys are ideal for agriculture. Steep slopes are unsuitable but may support terrace farming. 4. Water supply, regular rainfall or irrigation is essential for crop growth. B. Human factors. 1. Technology, use of machines, fertilizers, and irrigation improves productivity. 2. Labor, availability of farm workers affects the scale of farming. 3. Capital, money is needed for seeds, fertilizers, and equipment. 4. Market demand, determines which crops are profitable. 5. Government policies, subsidies, crop insurance, and research promote agricultural growth. 4. Types of agriculture. Agriculture varies according to land, climate, and economic development. The main types are, A. Subsistence agriculture practiced by small farmers mainly for family consumption, not for sale. Uses simple tools, family labor, and small land holdings. Found in Asia, Africa, and Latin America. Crops, rice, maize, wheat, pulses, vegetables. Subtypes, 1. Primitive subsistence farming, also called shifting cultivation or slash and burn farming. Farmers clear small forest areas, burn the vegetation, and grow crops. After 2-3 years, the soil loses fertility, and farmers move to another area. Common in Northeast India, Southeast Asia, and Africa. 2. Intensive subsistence farming, involves cultivating small land holdings intensively using maximum labor. Found in densely populated regions like India, China, Japan. Crops, rice, wheat, pulses, vegetables. B. commercial agriculture practiced mainly to sell crops and earn profit. Uses machines, fertilizers, irrigation, and scientific methods. Large farms with fewer workers. Found in developed countries and fertile plains. Crops: wheat, maize, sugarcane, cotton, tea, coffee. Subtypes: 1. Commercial grain farming, grown on large farms in temperate regions like prairies, USA/Canada, pampas, Argentina, steppes, Eurasia. Wheat and maize are main crops. 2. Plantation agriculture, large estates grow a single crop, monoculture, for export. Uses modern techniques and migrant labor. Crops: tea, coffee, rubber, cocoa, sugarcane, banana. Found in tropical regions, India, Sri Lanka, Malaysia, Brazil. C. Mixed farming involves both crop cultivation and livestock rearing. Provides manure, milk, meat, and income security. Common in Europe, North America, and parts of India. D. Dairy farming specialized in milk production and processing. Requires cool climate, good transport, and proximity to urban markets. Found in New Zealand, Denmark, Netherlands, and Punjab, India. E. Nomadic herding practiced by nomads who move from place to place with their animals. Found in Sahara, Arabia, Tibet, and Central Asia. Animals: camels, sheep, goats, reindeer, and yaks. Products: milk, meat, wool, hides. F. Shifting cultivation, traditional method of farming in forested areas. Known as Yam in Northeast India, Milpa in Central America, and Ladang in Indonesia. Environmentally destructive if not managed properly. 5. Major crops of the world. Crops are broadly divided into food crops and commercial crops. A. Food crops. 1. Rice, staple food for over half the world's population. Needs high temperature, 25 degrees C+, heavy rainfall, and flooded fields. Grown in China, India, Indonesia, Bangladesh, and Japan. 2. Wheat, grows in cool climate, 10–20 degrees C, with moderate rainfall. Major producers: China, India, USA, Russia, Canada. 3. Maize, corn, requires warm climate and moderate rainfall. Grown in USA, Brazil, China, India. 4. Millets and pulses, drought-resistant crops grown in semi-arid areas. Common in India and Africa. B. Commercial crops. 1. Cotton, needs warm climate and black soil. Major producers: India, USA, China, Egypt. 2. Sugarcane, needs hot climate and abundant water. Producers: India, Brazil, Cuba. 3. Tea and coffee, require humid tropical conditions. Tea: India, Sri Lanka, China, coffee: Brazil, Colombia, Ethiopia. 4. Rubber, needs heavy rainfall and high temperature. Grown in Malaysia, Indonesia, Thailand, India. 6. Agriculture in India. India is primarily an agricultural country. About 60% of its people depend on farming. India has diverse climates and soils, which allow the cultivation of a wide variety of crops. Major crops: rice, wheat, sugarcane, cotton, jute, tea, and pulses. States known for specific crops: Punjab, Haryana, wheat West Bengal, Bihar, Assam, rice and jute Maharashtra, Karnataka, sugarcane and cotton Kerala, Tamil Nadu, rubber, tea, coffee. Modern trends: use of tractors, irrigation canals, fertilizers, and high-yielding seeds since the Green Revolution, 1960s. Development of agro-based industries like sugar, textile, and dairy. Government initiatives for crop insurance, soil testing, and organic farming. 7. Problems of agriculture. Despite progress, agriculture faces several challenges. 1. Dependence on monsoon, irregular rainfall causes drought or floods. 2. Small land holdings, fragmented farms reduce productivity. 3. Traditional techniques, limited use of technology in rural areas. 4. Soil erosion and degradation, overuse of chemicals and deforestation. 5. Pests and diseases, reduce crop yield. 6. Lack of storage and marketing facilities, leads to post-harvest losses. 8. Measures to improve agriculture. 1. Irrigation development, more canals, wells, and drip systems. 2. Use of HYV seeds and fertilizers, to increase yield. 3. Mechanization, tractors, harvesters, and modern equipment. 4. Soil conservation, contour plowing, afforestation, and organic farming. 5. Scientific research, improved seeds, pest control, and weather forecasting. 6. Rural credit and cooperative farming, to support small farmers. 7. Training and education, for modern farming techniques. 9. Sustainable agriculture. Sustainable agriculture focuses on using natural resources wisely so that future generations can also benefit. It involves organic farming, without chemicals, water management, crop rotation, and mixed cropping. Use of renewable energy in farming. This approach balances productivity with environmental protection. 10. Summary of key points. Type: main feature, example regions, major crops, subsistence, small farms, simple tools, India, China, rice, pulses, commercial, mechanized, for-profit, USA, Canada, wheat, maize plantation, single crop, export-oriented, Sri Lanka, India, tea, coffee, rubber, mixed crops and animals, Europe, Punjab, wheat, dairy milk production, Denmark, New Zealand, milk, butter, nomadic herding, moving livestock, Sahara, Tibet, camels, sheep. 11. Conclusion: agriculture is the foundation of human civilization. It feeds the population, provides employment, and supports industries. Over time, it has evolved from primitive farming to modern scientific agriculture. However, growing population, soil degradation, and climate change demand a shift towards sustainable farming. By combining modern technology with traditional wisdom, we can ensure food security and protect the environment for generations to come. The health of the soil is the health of the nation, and the farmer is its true guardian. House with Garden. Chapter 10, Human Settlements, Summary. 1000 words. Introduction. Humans are social beings who live together in organized communities. These communities are known as human settlements. A settlement is any place where people build their homes and live permanently or temporarily. This chapter explains how settlements develop, the factors that influence their location, the types and patterns of settlements, and the differences between rural and urban settlements. It also highlights the impact of human activities on settlements and their surroundings. 1. Meaning of human settlement. A human settlement refers to a cluster or collection of houses where people reside and carry out their daily activities such as farming, trading, and other occupations. Settlements vary in size and function from small villages to large metropolitan cities. They are the centers of human civilization, providing shelter, security, and social interaction. 2. Evolution of human settlements. The history of settlements goes back thousands of years. 1. Early settlements, nomadic stage. Early humans were nomads. They moved from place to place in search of food and shelter. They lived in caves, forests, or near rivers. 2. Agricultural settlements. Around 10,000 years ago, humans learned to grow crops and domesticate animals. They began to live in one place. This led to permanent settlements. Settlements developed near rivers like the Nile, Indus, and Tigris because of fertile soil and water availability. 3. Industrial and modern settlements. With the Industrial Revolution, people moved to towns and cities for jobs in factories. Urban areas grew rapidly with better transport, communication, and trade facilities. Thus, from small huts along rivers to modern skyscrapers, human settlements have evolved with technology and society. 3. Factors affecting the location of settlements. Settlements do not develop randomly. Certain natural and human factors influence their location. A. Natural factors. 1. Availability of water, the most important factor. Settlements grow near rivers, lakes, and wells for drinking, irrigation, and transportation. Example, Delhi, on the Yamuna, Varanasi, on the Ganga. 2. Topography, relief. Flat and fertile plains encourage dense settlements. Steep mountains, deserts, and forests discourage habitation. Example, northern plains of India are densely populated, while the Himalayas are sparsely populated. 3. Climate, pleasant and moderate climates attract settlements. Very hot, cold, or wet areas, e.g., Sahara, Arctic, have few people. 4. Soil fertility, fertile soils support agriculture and large populations. Example, Ganga and Nile valleys. 5. Natural resources, minerals, forests, and fisheries attract settlements and industries. Example, mining towns like Haria or Dhanbad. B. Human factors. 1. Industrialization, leads to urban settlements near factories. 2. Transportation, roads, railways, and ports support town growth. 3. Economic opportunities, people migrate to places with jobs and markets. 4. Political and historical importance, capitals, forts, or pilgrimage centers become large settlements, e.g., Delhi, Mecca. 4. Types of settlements. Settlements are broadly classified into rural and urban based on population size, occupation, and lifestyle. A. Rural settlements found in villages and countryside. People mainly depend on agriculture, forestry, and fishing. Houses are spread out and surrounded by fields. Basic amenities are limited: water, electricity, transport. Features: low population density. Simple lifestyle. Close relationship with nature. Examples: villages of Maharashtra, Punjab, Uttar Pradesh, and Bihar. B. Urban settlements found in towns and cities. People are engaged in non-agricultural occupations like industry, trade, and services. High population density and better infrastructure, schools, hospitals, roads, etc. Features: complex lifestyle. High-rise buildings and crowded neighborhoods. Facilities like markets, offices, and recreation centers. Examples: Mumbai, Delhi, Kolkata, Pune, and Chennai. 5. Patterns of rural settlements. The pattern of settlement refers to the way houses and buildings are arranged in a village. It depends on the terrain, water availability, and land use. 1. Clustered or nucleated settlements. Houses are close together around a common feature like a well, temple, or road. Found in fertile plains and river valleys. Example: villages in Uttar Pradesh and Bihar. 2. Dispersed settlements. Houses are scattered and far apart. Found in hilly, forested, or desert regions. Example: villages in Rajasthan and Himachal Pradesh. 3. Linear settlements. Houses built along a road, river, or canal. Common in coastal or riverine areas. Example: villages along the Ganga or highways. 4. Radial or circular settlements. Houses arranged around a central feature like a market or temple. Example: some ancient towns and tribal villages. Each pattern reflects the natural environment and socio-economic life of the people. 6. Types of urban settlements. Urban settlements vary in size and function. Type: population. Example: town, small population; local markets, Alibag, Wardha city, large population; administrative and industrial functions, Nagpur, Pune metropolis, very large city with wide influence, Mumbai, Delhi megacity, population over 10 million, Mumbai, Tokyo conurbation/urban agglomeration, merging of several cities and towns, Mumbai metropolitan region. 7. Functions of urban settlements. Cities develop based on their functions or activities. 1. Administrative centers, capitals or district headquarters, e.g., Delhi, Mumbai. 2. Industrial centers, manufacturing hubs, e.g., Ahmedabad textiles, Jamshedpur steel. 3. Commercial centers, markets and trade hubs, e.g., Mumbai, Kolkata. 4. Transport centers, ports and railway junctions, e.g., Chennai, Visakhapatnam. 5 religious and cultural centers, pilgrimage and heritage sites, e.g., Varanasi, Madurai. 6 educational centers, universities and research institutions, e.g., Pune, Bengaluru. Many cities perform multiple functions, making them multifunctional settlements. 8. Differences between rural and urban settlements. Basis: rural settlements, urban settlements, occupation, agriculture and primary activities, industry, trade, services, population density, low high infrastructure, limited advanced lifestyle, simple and traditional, modern and complex environment, closed to nature, modified by human activity. Rural and urban areas are interdependent. Villages provide food and raw materials, while cities provide manufactured goods and services. 9. Problems of urban settlements. Rapid urbanization has led to several challenges: 1. Overcrowding, too many people in limited space. 2. Housing shortage, slums and inadequate living conditions. 3. Traffic congestion, too many vehicles cause pollution and accidents. 4. Pollution, air, water, and noise pollution due to industries and transport. 5. Unemployment, migration leads to competition for jobs. 6. Waste disposal, improper waste management causes health hazards. 7. Water and power shortages, demand exceeds supply in big cities. Solutions include better urban planning, public transport, and waste management systems. 10. Problems of rural settlements. Rural areas also face difficulties: 1. Lack of infrastructure, poor roads, electricity, and schools. 2. Limited healthcare and education. 3. Seasonal employment, dependence on monsoon for farming. 4. Migration, people move to cities for better opportunities. 5. Poverty and indebtedness, small farmers often face financial problems. Rural development programs and improved connectivity can reduce these issues. 11. Modern trends in settlements. Modern settlements are changing rapidly due to technological progress and population growth. 1. Urbanization, more people are moving from villages to towns. 2. Smart cities, use of digital technology for transport, power, and waste management. 3. Satellite towns, smaller towns developed near big cities to reduce crowding. 4. Eco-villages and green cities, focus on environmental sustainability and renewable energy. 5. Migration and globalization, cultural mixing and economic interdependence between regions. 12. Sustainable settlements. To make settlements sustainable, plan cities with green belts and parks. Promote public transport and reduce pollution. Encourage rainwater harvesting and waste recycling. Maintain balance between rural and urban development. A sustainable settlement ensures good living conditions for present and future generations. 13. Key points to remember. Human settlements are places where people live and work. Settlements are influenced by natural and human factors. 2 main types: rural, agricultural, and urban, industrial. Settlement patterns: clustered, dispersed, linear, circular. Rapid urbanization causes environmental and social challenges. Sustainable development ensures better quality of life for all. 14. Conclusion. Human settlements reflect how people adapt to their surroundings. From small rural villages to vast urban metropolises, settlements reveal the progress of human society. However, unplanned growth leads to pollution, overcrowding, and inequality. Therefore, we must promote balanced regional development, combining rural upliftment with sustainable urban planning. A well-planned settlement is not just a place to live, but a community that breathes, grows, and sustains future generations. Mount Fuji. Chapter 11, Contour Maps and Landforms, Summary 1000 words, Introduction to study the shape and features of the Earth's surface. Geographers use maps. One special type of map that shows height, slope, and shape of landforms is a contour map. A contour map helps us visualize the 3D surface of the Earth, hills, valleys, plateaus, plains, on a flat piece of paper. This chapter explains what contours are, how to read contour maps, and how different landforms are represented by contour patterns. 1. What is a contour line? A contour line is an imaginary line on a map joining all points of the same height, elevation, above mean sea level. For example, if we join all the points that are 100 meters above sea level, we get the 100 m contour line. Similarly, another line may show 200 m, 300 m, and so on. Contours show the relief of the land, that is, the rise and fall of the terrain. 2. Characteristics of contour lines. Contour lines follow certain scientific rules. 1. All points on a contour line are at the same height. 2. Contours never cross each other, because one place cannot be at two different heights. 3. Contour spacing indicates the slope, close, crowded, contours steep slope. Far apart, wide, contours gentle slope. 4. Contours form closed loops. Small, closed contours with increasing height toward the center represent a hill or mountain. Closed contours with decreasing height toward the center represent a depression or basin. 5. Contour interval, the vertical difference between two consecutive contours, is constant for a given map, e.g., 20 m, 50 m, or 100 m. 3. Contour interval. The contour interval is the difference in height between two consecutive contour lines. It depends on the scale of the map, the nature of the terrain. Example, if the contour interval is 20 m and one contour line is marked 200 m, the next will be 220 m. For flat areas, a small contour interval, e.g., 10 m, is used. For mountainous areas, a large contour interval, e.g., 100 m, is used. 4. Uses of contour maps. Contour maps are extremely useful for understanding the Earth's surface features. They are used by 1. Geographers to study landforms, elevation, and slope. 2. Engineers for constructing roads, bridges, dams, and tunnels. 3. Town planners to decide suitable areas for housing, industries, and drainage systems. 4. Military personnel to plan routes and positions in hilly terrain. 5. Environmental scientists to study erosion, drainage, and watershed patterns. Contours help convert two-dimensional maps into a three-dimensional mental image of the land. 5. Identifying slope on contour maps. The slope of land means how steep or gentle it is. It can be identified from the spacing of contour lines. 1. Steep slope, contours are very close together. Height changes rapidly over a short distance. Common in mountain and hill areas. 2. Gentle slope, contours are widely spaced. Height changes gradually. Common in plains and plateaus. 3. Concave slope, contours are close at the top and wide at the base. Indicate slope becoming gentle downward. 4. Convex slope, contours are wide at the top and close at the base. Indicate slope becoming steeper downward. These patterns help in identifying the shape and gradient of terrain. 6. Representation of landforms on contour maps. Different landforms have distinct contour patterns. Learning to identify them helps interpret maps correctly. A. Hill or mountain contours form concentric circles. Elevation increases toward the center. The smaller the circle, the higher the elevation. Example, hill peaks in Deccan Plateau. B. Plateau flat elevated area. Contours are widely spaced at the top and steep at the edges. The topmost contour is often almost flat. C. Valley contours form a V shape pointing toward higher ground, upstream. Indicates the course of a river or stream flowing through the valley. The narrowness of the V shows how steep the valley is. D. Ridge contours form a V shape pointing toward lower ground, downstream. Represents a long elevated crest between two valleys. E. Spur small projection or extension of high ground into lower ground. V shape points away from high ground. F. Depression or basin contours form closed loops with hachure marks, short lines, pointing inward. Shows a low-lying area like a crater or sinkhole. G. Pass or col low point between two peaks on a ridge. represented by a saddle-shaped contour. Used for constructing mountain roads or railways. H. Cliff or escarpment contours are very close or touching each other. Indicates a vertical or near vertical slope. 7. Reading and interpreting a contour map. To read a contour map effectively, one must, 1. Check the contour interval to know how much height each line represents. 2. Note the contour values. They show whether elevation increases or decreases. 3. Observe contour spacing to determine slope type. 4. Identify patterns: concentric, V-shaped, parallel, etc. 5. Understand direction of flow. Rivers flow from high to low contours. By combining all these clues, one can visualize the 3D shape of the land. 8. Contours and drainage. Contour maps also help in studying drainage patterns, the arrangement of rivers and streams. Rivers flow from higher to lower contours. V-shaped contours pointing uphill show valleys and river courses. The closer the contours, the steeper the river slope. Wider spacing means a gentle flow. Such information helps in flood control, dam building, and irrigation planning. 9. Contour cross-section. A cross-section is a side view of the land obtained from a contour map. Steps: 1. Draw a line across the area you want to study, called a baseline. 2. Mark where it cuts the contour lines. 3. Plot these contour heights on graph paper to create a profile showing hills, valleys, or plains. Cross-sections help engineers and geographers visualize the actual relief of the land. 10. Landforms and human life. The physical shape of the land, as shown by contours, affects how humans live. Landform: human activity, plains, dense population, agriculture, transport, plateaus, mining, grazing, industry, hills/mountains, tourism, tea and coffee plantations, valleys, settlements and irrigation, deserts, sparse population, nomadic life. Contour knowledge helps people choose safe and suitable sites for development. 11. Advantages of contour maps. 1. Shows height and shape of land clearly. 2. Helps identify slopes and landforms. 3. Useful for construction projects like roads and dams. 4. Assists in watershed and irrigation planning. 5. Provides a 3D view of terrain from a flat map. 6. Essential for military and rescue operations. Thus, contour maps are indispensable tools in geography, engineering, and environmental studies. 12. Limitations of contour maps. Although contour maps are very useful, they have some limitations. 1. They require skill to interpret correctly. 2. They do not show vegetation, soil, or population details. 3. The actual height between contours, interval, may hide small variations in land. 4. They can be confusing for beginners due to complex patterns. Despite these limits, contour maps remain the most scientific way to show relief. 13. Modern tools for mapping landforms today: geographic information systems, GIS, satellite images, and digital elevation models, DEMS, are used to create digital contour maps. They give precise height data. Can be used to simulate floods, landslides, or urban planning. Modern maps can be easily updated and combined with data on climate, vegetation, and population. Thus, technology has made contour mapping faster, more accurate, and interactive. 14. Key points to remember. Concept explanation: contour line joins points of equal elevation. Contour interval: difference in height between two contours. Close contours: steep slope, wide contours, gentle slope. V-shaped contours, pointing upstream, river valley. Concentric circles, increasing inward, hill or peak. Hachured contours, decreasing inward. Depression uses engineering, planning, geography, defense. Modern tools: GIS, satellite mapping. 15. Conclusion: contour maps are essential for understanding the relief and shape of the Earth's surface. By studying contour lines, we can visualize how high or low the land is, how steep a mountain stands, or how a river flows through a valley. They are used in everything from building roads and cities to studying natural disasters and environmental conservation. Understanding contours teaches us that geography is not flat, it's a world of height, depth, and form. A contour map is more than lines on paper, it is a story of the land, drawn in curves and elevations. White heavy check mark. Excellent. Here are 5 important 10-mark questions with detailed answers based on Chapter 11, Contour Maps and Landforms from your Maharashtra Board Class 7 Geography textbook, English. Each answer is written in exam-style format, clear, structured, and easy to remember. Q1. What are contour lines? Explain their characteristics and importance. Answer. A contour line is an imaginary line joining all points having the same height above mean sea level on a map. These lines show the elevation and shape of the land on a flat surface. Characteristics of contour lines: 1. Equal height, all points on one contour are at the same elevation. 2. Never intersect, 2 contours never cross each other because a place cannot have 2 different heights. 3. Spacing shows slope, close contours steep slope. Wide contours gentle slope. 4. Closed loops, contours always form closed shapes large or small. 5. Uniform interval, the difference in height between 2 successive contours, called contour interval, remains constant on a map. 6. V-shapes, contours form V-shapes that point toward high ground for valleys and away for ridges. Importance: contour maps help identify landforms like hills, valleys, plateaus, and plains. They are used for construction, planning roads, dams, and military operations. They give a 3D idea of the Earth's surface on a 2D map. Thus, contour lines are essential for understanding the relief and elevation of any region. Q2. Explain how different landforms are represented on contour maps. Answer. Contour maps show various landforms by the pattern and spacing of contour lines. Each landform has a unique contour shape. 1. Hill or mountain, shown by concentric circles with height increasing toward the center. The smaller the inner circles, the higher the peak. 2. Plateau, contours form wide, flat-topped circles. Contours are close at the edges and far apart at the top, showing a flat elevated area. 3. Valley, contours form a V shape pointing toward high ground, upstream. Indicates the course of a river. 4. Ridge, V-shaped contours point away from high ground. Represents a long elevated crest. 5. Depression or basin, closed loops with hachure marks, short inward lines. Shows a hollow or crater-like feature. 6. Pass or COL, saddle-shaped gap between 2 peaks, used for roads and railways. By observing these patterns, one can easily visualize the shape and height of landforms from contour maps. Q3. What is a contour interval? How does the spacing of contour lines indicate the nature of slope? Answer. A contour interval is the vertical difference in height between 2 consecutive contour lines on a map. It remains constant throughout a map and helps measure the relative height of features. Example: if one contour line is 200 meters and the next is 220 meters, the contour interval is 20 meters. Relation between contour spacing and slope: 1. Close spacing steep slope, contour lines are very near each other. Indicates rapid change in height, mountain areas. 2. Wide spacing gentle slope, contours are far apart. Height changes slowly, plains. 3. Irregular spacing uneven slope, mixed spacing indicates variable land surface. 4. Contours touching vertical slope or cliff, extremely close or overlapping contours show a sudden drop or rise. Importance: understanding contour spacing helps engineers, planners, and geographers determine the steepness, drainage, and suitability of land for construction, roads, or agriculture. Q4. Explain the uses of contour maps in different fields. Answer. Contour maps have a wide range of practical uses in geography, engineering, and planning. 1. Geographical studies, helps in understanding relief features like hills, valleys, and plateaus. Used for comparing elevations of different regions. 2. Engineering and construction, essential for designing roads, railways, canals, tunnels, and dams. Helps in selecting suitable sites for buildings and bridges. 3. Military use, used for planning troop movements and defenses in hilly regions. For town and regional planning, helps planners design drainage systems, layout of roads, and housing according to slope and elevation. 5. Environmental management, used to study watersheds, flood zones, and soil erosion patterns. 6. Tourism and adventure, contour maps help mountaineers and trekkers find routes and elevations safely. Conclusion, contour maps are vital tools that convert flat maps into a 3D understanding of terrain, enabling safe, efficient, and scientific land use planning. Q5. Differentiate between steep slope, gentle slope, concave slope, and convex slope with reference to contour maps. Answer, the slope of land indicates how steep or flat it is. Contour maps show slopes through the spacing and shape of contour lines. Type of slope contour spacing description examples / region steep slope contours very close together height increases rapidly over a short distance mountain slopes of Himalayas gentle slope contours far apart height increases slowly, nearly flat land plains of Ganga or Deccan Plateau top concave slope contours close at top, wide at base slope becomes gentle downward foothills or river valleys convex slope contours wide at top, close at base slope becomes steep downward escarpments or hill. Bases conclusion, the spacing of contours provides a clear picture of how steep or gentle the terrain is. This knowledge helps in construction, agriculture, transport planning, and environmental studies. White heavy checkmark summary of key concepts, for quick revision contour line, joins points of equal elevation. Contour interval, vertical difference between consecutive contours. Close spacing steep slope, wide spacing gentle slope. Contour patterns identify landforms like hills, valleys, plateaus. Uses, engineering, geography, military, urban planning. Perfect. Here are 5 more 10-mark questions with full answers based on Chapter 11, Contour Maps and Landforms from your Maharashtra Board Class 7 Geography textbook, English. These questions are descriptive, analytical, and ideal for long answer writing in exams. Q6. Describe the different types of slopes shown on contour maps. Give diagrams to explain. Answer, a slope is the inclination or steepness of the land surface. The spacing and shape of contour lines on a map show the type of slope. One steep slope, contour lines are very close together. Height increases or decreases rapidly. Common in mountainous areas like the Himalayas. 2 gentle slope, contour lines are widely spaced. Height changes gradually. Found in plains or plateaus. 3 concave slope, contours are close together at the top and wider at the bottom. Slope becomes gentler downward. Common at foothills and valleys. 4 convex slope, contours are wide at the top and close at the bottom. Slope becomes steeper downward. Found on hill bases or escarpments. 5 irregular slope, uneven spacing of contours. Indicates undulating or uneven terrain. Understanding slope is important for engineering, agriculture, and land use planning. Q7. How can contour maps be used to identify drainage patterns and river valleys? Answer, contour maps are very useful for studying drainage systems, that is, the arrangement and flow of rivers and streams. 1. Identifying river valleys, V-shaped contours that point toward higher land indicate a river valley. The river flows opposite to the direction of the V. The closer the contours, the steeper the valley. 2. Identifying river flow direction, contours always decrease in height downstream. Rivers flow from higher contours to lower contours. 3. Identifying floodplains, wide-spaced contours along a river show flat, low-lying floodplains. 4. Identifying waterfalls and rapids, sudden drop in contour values along a river course indicates waterfalls or rapids. 5. Identifying drainage basins, the area bounded by ridges and high contours from which rivers originate. Conclusion, contour maps help visualize the shape and slope of river valleys, making them vital tools in irrigation, dam building, and flood control. Q8. Write a note on the advantages and limitations of contour maps. Answer, advantages, 1. Shows relief clearly, depicts height, shape, and slope of land. 2. Three-dimensional view, helps visualize the Earth's surface on a flat map. 3. Accurate measurements, height, gradient, and distances can be calculated. 4. Useful in engineering, helps design roads, railways, and canals. 5. Environmental planning, used for watershed, soil, and erosion studies. 6. Military and navigation, helps in route planning and defense operations. 7. Permanent record, provides detailed, measurable information of terrain. Limitations, 1. Difficult to read for beginners. 2. No information about vegetation, soil, or human activities. 3. Cannot show small variations in relief. 4. Cluttered appearance in hilly areas. 5. Requires skill and training to interpret correctly. Conclusion, despite limitations, contour maps remain the most scientific and precise method to represent the relief and slope of land. Q9. Explain the relationship between contour lines and land elevation. How do contours help in understanding the relief of an area? Answer, contour lines are drawn to represent the height or elevation of land above mean sea level. One representation of elevation, every contour line connects points of equal height. Example, a contour marked 200 m means all points on that line are 200 m above sea level. 2. Understanding elevation changes, when moving across contours, height increases or decreases by a fixed contour interval, e.g., 20 m. This helps determine the relative height of landforms. 3. Understanding relief, land shape close contours steep terrain, mountains. Wide contours flat or gentle terrain, plains. Concentric contours hill, V-shaped valley, hatch-eared depression. 4. Calculation of gradient, gradient equals vertical rise divided by horizontal distance. Helps engineers and geographers measure slope accurately. Conclusion, contour lines make it possible to convert a flat map into a 3D visualization, showing the elevation, slope, and relief of the land in detail. Q10. Discuss how modern technology like GIS and remote sensing has improved the preparation and use of contour maps. Answer, modern mapping technology has revolutionized how contour maps are prepared and analyzed. 1. Use of GIS, Geographic Information System. GIS stores and analyzes geographic data digitally. It automatically generates digital contour maps using elevation data. Enables overlay of other information like soil, vegetation, and land use. Useful for urban planning, disaster management, and resource mapping. 2. Remote sensing and satellites. Satellites capture aerial images and elevation data of the Earth's surface. Remote sensing provides accurate, up-to-date contour data even in inaccessible areas. Combined with GPS, it helps in real-time mapping and monitoring of changes. 3. Digital elevation models, DEMS 3D digital representations of terrain generated from satellite data. Used in climate modeling, flood prediction, and infrastructure design. 4. Advantages over traditional mapping, faster, more accurate, and can be updated easily. Allows 3D visualization and simulation of terrain. Conclusion, GIS and remote sensing have made contour mapping more scientific, efficient, and dynamic, turning maps into powerful tools for planning and environmental management. White heavy checkmark. Quick recap, 10, key exam points. 1. Contour line same elevation points. 2. Contour interval vertical difference in height. 3. Close contours steep slope. 4. V-shaped contours river valleys. 5. Hatch-eared contours depressions. 6. Uses engineering, military, geography. 7. Landforms hill, plateau, ridge, spur, valley. 8. Slopes steep, gentle, concave, convex. 9. Modern mapping. GIS, DEM, satellite. 10. Contour maps equals visual language of the Earth's surface. Blue Book Maharashtra Board Class 7 Geography 10 mark questions and answers, set covering all chapters, Q1. Chapter 1, How Seasons Occur Part 1, Question, explain why the duration of day and night changes throughout the year. Answer, the Earth's rotation and revolution, along with the tilt of its axis, cause variation in the duration of day and night. 1. The Earth's axis is tilted at 23½ degree from the perpendicular to the plane of its orbit. 2. As the Earth revolves around the Sun, one hemisphere tilts toward the Sun and the other away from it. 3. The hemisphere tilted toward the Sun experiences longer days and shorter nights, while the other has shorter days and longer nights. 4. On June 21st, summer solstice, the northern hemisphere has the longest day. On December 22nd, winter solstice, it has the shortest day. 5. On March 21st and September 23rd, equinoxes, both hemispheres receive equal sunlight. Day and night are equal. Conclusion, the changing duration of day and night results from the tilted axis and revolution of the Earth, which together produce the cycle of seasons and daylight variation. Q2. Chapter 4, Air Pressure. Question, what is air pressure? Explain the factors affecting it. Answer, air pressure is the force exerted by the weight of air on the Earth's surface. It is measured using a barometer and expressed in millibars. Factors affecting air pressure. 1. Altitude. Pressure decreases with height because air becomes thinner. Example, hill stations have lower air pressure than coastal areas. 2. Temperature. Warm air expands and becomes lighter, creating low pressure. Cold air contracts and becomes heavier, creating high pressure. 3. Water vapor. Moist air is lighter than dry air. Areas with more humidity, like oceans, have lower pressure. 4. Rotation of the Earth causes pressure belts and movement of air, winds. Conclusion, differences in air pressure cause winds, cloud formation, and rainfall, which are essential for maintaining the Earth's weather balance. Q3. Chapter 6, Natural Regions. Question, what are natural regions? Describe the main natural regions of the world. Answer, natural regions are large areas of the Earth that have similar climate, vegetation, and wildlife. Human life and activities also vary according to these natural conditions. Main natural regions. 1. Equatorial region, hot and wet all year, dense evergreen forests found in Amazon Basin, Congo Basin, Southeast Asia. 2. Tropical grasslands, savanna hot with wet and dry seasons. Tall grass and scattered trees. Example, Africa, Brazil. 3. Desert region, very dry, hot days and cold nights. Sparse vegetation like cacti. Examples, Sahara, Dar. 4. Temperate grasslands, moderate rainfall, short grass. Known as prairies, pampas, steppes. 5. Mediterranean region, hot, dry summers and cool, wet winters. Olive, grapes, citrus fruits grow here. 6. Tundra region, very cold, covered with snow most of the year. Found in Arctic and Antarctica. Conclusion, each natural region has its own distinct climate, vegetation, and human lifestyle, showing how nature shapes life on Earth. Q4. Chapter 9, Agriculture. Question, explain the major types of agriculture practiced in the world. Answer, agriculture varies according to climate, soil, population, and technology. The major types are, 1. Subsistence agriculture, small farms, crops grown for family use. Common in Asia, Africa. Uses simple tools and family labor. 2. Intensive subsistence farming, high population areas like India and China. Small land, high labor, rice, and wheat grown. 3. Commercial agriculture, large-scale farming for profit using machines and fertilizers. Found in USA, Canada, Australia. 4. Plantation farming, large estates grow a single crop for export, monoculture. Crops, tea, coffee, rubber, sugarcane. Found in India, Sri Lanka, Malaysia. 5. Mixed farming, combination of crop farming and livestock rearing. Common in Europe. 6. Nomadic herding, People move with animals for pasture. Common in deserts and cold regions. Conclusion: agriculture is the backbone of human life, and its types reflect adaptation to different climates, economies, and cultures. Q5. Chapter 10, Human Settlements. Question: distinguish between rural and urban settlements. Explain their characteristics and interdependence. Answer: settlements are places where people live and work. They are classified into rural and urban based on population, occupation, and lifestyle. Basis: rural settlements, urban settlements, location countryside or villages, towns and cities, occupation agriculture, fishing, forestry, industry, trade, services, population density, low-high, lifestyle, simple and traditional, modern and complex, infrastructure, poor transport, limited facilities, developed transport and services, environment close to nature, highly modified by humans, interdependence, villages provide food, raw materials, and labor to cities. Cities provide manufactured goods, education, healthcare, and employment to rural areas. Conclusion: rural and urban settlements are complementary parts of human civilization. Balanced development of both ensures a sustainable and equitable society. White heavy check mark. Summary of covered chapters: 1. Seasons, day-night variation. 2. Air pressure factors and effects. 3. Natural regions, types of climates and vegetation. 4. Agriculture, major types. 5. Human settlements, rural vs urban. Excellent. Let's complete your set. Here are 5 more 10-mark geography questions with full, exam-ready answers covering the remaining chapters from your Maharashtra Board Class 7 Geography textbook, English chapters 2, 3, 5, 7, and 8. Each answer is written in clear, structured form for full marks in written exams. Blue Book Maharashtra Board Class 7 Geography 10-mark questions and answers, final set. Remaining chapters, Q1. Chapter 2, the Sun, the Moon, and the Earth. Question: describe the motions of the Earth and explain their effects on human life. Answer: the Earth performs 2 main motions, rotation and revolution. Both motions are responsible for the occurrence of day, night, and seasons. 1. Rotation: the Earth spins on its axis from west to east once every 24 hours. Causes day and night. The side facing the Sun has day, and the opposite side has night. Rotation also causes sunrise, sunset, and apparent movement of the Sunday too. Revolution: the Earth revolves around the Sun in an elliptical orbit once every 365 1/4 days. Along with the tilt of the Earth's axis, 23 1/2 degree, revolution causes seasons. Different parts of the Earth receive different amounts of sunlight during the year. Effects on human life: determines time and calendar. Influences agriculture and weather patterns. Affects temperature and duration of daylight. Conclusion: the rotation and revolution of the Earth make life dynamic by creating the rhythm of day, night, and seasonal changes essential for living beings. Q2. Chapter 3, Tides. Question: what are tides? Explain their types and importance. Answer: tides are the regular rise and fall of ocean water levels caused by the gravitational pull of the Moon and the Sun on the Earth's surface. Types of tides: 1. High tide, water level rises to its maximum height. Occurs on the side of Earth facing the Moon and the opposite side due to centrifugal force. 2. Low tide, water level falls to its minimum height. Occurs between 2 high tides. 3. Spring tide, occurs on full moon and new moon days. Sun, Moon, and Earth are in a straight line. Highest high tide and lowest low tide. 4. Neap tide, occurs on quarter moon days. Sun and Moon are at right angles. Tidal range is least. Importance of tides: navigation, helps ships enter and leave port safely. Fishing, fishermen use tides for fishing activities. Electricity, used for tidal power generation. Cleaning coasts, washes away waste and keeps shores clean. Conclusion: tides are vital for marine life, navigation, and coastal balance, showing the strong link between the Moon and Earth's water systems. Q3. Chapter 5, Winds. Question: What are wines? Explain the different types of wines found on Earth. Answer: Wind is the horizontal movement of air from high pressure to low pressure areas. It helps distribute heat and moisture across the Earth's surface. Types of wines: 1. Permanent, planetary, wines, blow throughout the year in fixed directions. Caused by pressure belts and Earth's rotation. Examples: trade wines, blow from subtropical high pressure to equatorial low pressure. Westerlies, blow from subtropical high to subpolar low latitudes. Polar easterlies, from poles to subpolar regions. 2. Seasonal wines, monsoon wines change direction with the seasons. Example: southwest monsoon in summer brings rain to India. Northeast monsoon in winter is dry. 3. Local wines, blow in small areas for short durations. Examples: land and sea breezes, daytime sea breeze, night land breeze. Mountain and valley wines, day up the valley, night down the valley. Hot wines, Lu, in Indian plains. Conclusion: wines help maintain climate balance, cause rainfall, and influence navigation, weather, and agriculture. Q4. Chapter 7, Soils. Question: What are the major types of soils found in India? Describe their characteristics. Answer: India has diverse climates and rocks, giving rise to several types of soils, each suitable for specific crops. 1. Alluvial soil, found in northern plains, Ganga, Brahmaputra. Formed by river deposits. Fertile, rich in potash and lime. Crops: rice, wheat, sugarcane. 2. Black soil, Regur, found in Maharashtra, Gujarat, MP. Formed from lava rocks, basalt. Retains moisture, rich in iron and lime. Ideal for cotton. 3. Red soil, found in Tamil Nadu, Karnataka, Odisha. Red color due to iron oxide. Less fertile but productive with fertilizers. 4. Laterite soil, found in Western Ghats and NE India. Heavy rainfall areas, leached of nutrients. Crops: tea, coffee, cashew. 5. Arid soil, found in Rajasthan and Gujarat. Sandy, saline, poor in humus. Grows millets after irrigation. 6. Mountain soil, found in Himalayas. Thin, immature, but fertile in valleys. Crops: tea, apple, maize. Conclusion: each soil type supports particular crops. Proper soil conservation, afforestation, contour plowing, ensures long-term fertility and sustainable farming. Q5. Chapter 8, How Seasons Occur Part 2. Question: Describe how the revolution of the Earth and the tilt of its axis cause different seasons. Answer: The Earth's revolution around the Sun and its axis tilt of 23½ degree are the main reasons for the occurrence of seasons. 1. Revolution: the Earth revolves around the Sun in 365 1/4 days. The position of the Earth changes continuously, changing sunlight intensity. 2. Tilt of axis: the Earth's axis is tilted and remains parallel throughout its revolution. This causes one hemisphere to receive more direct sunlight while the other gets slanting rays. 3. 4 main seasons: summer, June 21st, Northern Hemisphere tilts toward the Sun, long days, short nights. Winter, December 22nd, Southern Hemisphere tilts toward the Sun, short days, long nights. Spring, March 21st, sun rays fall directly on the equator, equal day and night. Autumn, September 23rd, equal sunlight again on both hemispheres. 4 opposite seasons: when it is summer in India, Northern Hemisphere, it is winter in Australia, Southern Hemisphere. Conclusion: thus, the Earth's tilt and revolution create the beautiful cycle of seasons, influencing weather, agriculture, and all forms of life on Earth. White heavy check mark. Summary of chapters covered. Chapter topic: focus 2 Sun, Moon, and Earth. Earth's motions. 3 Tides, types and importance. 5 Wines, types of wines. 7 Soils, types and features. 8 Seasons, Part 2, Revolution and tilt dash. Would you like me to now make a combined PDF file of all these 10 marked questions and answers, total 20 sets, covering all 11 chapters, for easy printing and study?